Okay, so we're going to be doing 3.2 tonight, and I'm leaving for a conference tomorrow, so that's why the media guy is here. We're filming so that the Friday morning class can see the video. All right, so everybody turn around and wave to the morning class. Hi, morning class. All right, so let's look at 3.2. Are we good? We ready? Okay, 3.2, we're going to be looking at quadratic functions. If you had 320 or Algebra 2, this should be a review for you. And once again, if this is something that's been a while, you need to spend that extra time in the math lab because these are the fundamentals. These are the things that you need to have to build on. All right, so let's look at, first of all, what the heck is a quadratic function? A quadratic equation is ax squared plus bx plus c equals 0. This is called standard form for a quadratic. And a lot of the things that we're going to be doing has to be in standard form. All right, so then talking about a quadratic function, what's the difference? Well, we've already talked about function notation, right? We call them Fred. So a quadratic function means that instead of writing ax squared plus bx plus c over and over again, we're going to give him a nickname. This is Fred. So that we can just say, go see the f function instead of having to write this over and over again. You're welcome to take a picture if you want to. All right, everybody got it? Next. All right, we talked about the zeros of a function. When we did linear functions, how many places does a line hit the x-axis? Once. Okay, so now we're going to step it up. Now we're on x squared. So we're not on lines anymore. So now the question is, what about the zeros of a quadratic function? And we know already that that is where the function is equal to 0. It's where it hits the x-axis. So where does it hit the x-axis? Where ax squared plus bx plus c equal to 0. How do we solve that? Well, the first way is by factoring, which we already know how to do. And we're also going to look at some other ones tonight. All right, so let's look at solving for roots. The first way that we're going to review is by factoring. If this factors right here, it's going to factor into two different pieces, equals 0. Notice the second part here, the zero product property. This is our bread and butter here for factoring. If a times b is 0, I am thinking of two numbers, and I'm multiplying those two numbers together in my head, and when I do that, I get a 0. What does that mean about a and b? One of them has to be 0. So this is called the zero product property or the zero factor property. If a times b is 0, then a is 0 or b is 0. So that means if this factored, I'll just make some factors up here. If this factors to x plus 3x minus 5 equals 0, now you have a product. This is your a, this is your b. So all you have to do is set each piece equal to 0 and solve. All right, so how many answers do we have? We have 2 answers. So we have in a set, and we talked a lot about the squigglies on that first test, the set is -3 and 5. And how do you know that those are correct? Plug them back in. Plug them back into the original, which in this case would be x squared minus 2x minus 15, and see if they work. So this is if it will factor. Now, in the world of quadratics, how many of them actually factor? This many. Right? The ones that they rig to put in your textbook are the only ones who actually factor. So what do we do about all the millions and billions out there that do not factor? I'm so glad you asked. That's why we're here tonight, to review these other methods. The first method we're going to look is the square root method. All right, let's start with x squared equals 4. If x squared equals 4, then the way that we did this before is by factoring. So when you solve by factoring, you first have to put it in standard form, ax squared plus bx plus c equals 0. So what do we need to do to put this into standard form? How do you make this look like this? Move the 4 over. So we're going to move that 4 over, and we have x squared minus 4 equals 0. Now, as some of you learned on the test, x squared minus 4 factors to x plus 2, x minus 2. Is there just one answer? Hint, hint, on the domain there was 2 answers. So right here, when we set each piece equal to 0, then we have 2 answers. X is negative 2 or x is positive 2. And on these, I want you to write it as a set. If there's more than one answer, then the kosher thing to do is to write it as a set. This is something that we're losing because on the computer, they just let you put it in there and separate it with a comma, right? Now, if there's more than one answer, the computer understands that it can be in either order, so you don't have to worry about that. So if you put 2, negative 2, it's okay with that. Okay? All right, now, that was a squirrel. All right, so now let's get back to the point here. The point was, we know that our answers are negative 2 and positive 2, right? Everybody agree with that? We did it by factoring. Everything worked out. Now, what we're looking at now is right here. We're looking at doing this in a different method. We have an x squared. What we want is an x. How do you magically turn an x squared into an x? And the nice thing about an equation is that you can do pretty much anything you want as long as you do what? You have to do the same thing to both sides. So the square root of x squared is x, but what is the square root of 4? And notice right here, how many answers did we have? It's not just 2. It is plus or minus. All right, so back over here. Whenever we do the square root method, write yourself a note. I will not forget to write plus or minus. Every time you do the square root method, you have to do plus or minus. All right, so let's go back here and start with a nice, once a year on your birthday, factorable quadratic. All right, so how long has it been since you factored? Might be wanting to do a little review there. All right, so this is actually the easy kind. X squared came from x times x. The last term is negative. What does that mean about my signs? 1 plus, 1 minus. So I need two numbers that multiply to 6 and subtract to 1. Now can I just throw them in there any way I want? You subtract and take the sign of the larger number. All right, so that means I have 2 and 3, but I need the 3 to be positive. All right, so on the factoring, right now we have factored this right here. But we're not done yet. We're not just factoring to factor. We are solving. So at this point right here, I would highly recommend that you stop, do first, outer, inner, last. Make sure that it's right, because we're not done yet. That's just the first step. Now we're going to go on to the next step. Set each piece equal to 0 and solve. And in college algebra, I always have people, oh, I can do this in my head. And then they forget, and they say -2 and +3. What happens when you solve these equations? They change signs. So if you want to be hot stuff and do that in your head, make sure you change the sign. All right, what's our answers? And I want you to write that as a set, and you can check it by plugging it back in. All right, so this is solving by factoring. Every once in a while it happens. Any questions on the steps here? All right, moving on then. The square root method. What's different is that for most of our methods, we want to put it into standard form. Ax squared plus bx plus c equals 0. We want it in standard form. The square root method is the exception to that rule. We don't want it in standard form. What we want is the squared term to be on one side and the number on the other. Now, how the heck am I supposed to know this? Well, what's the difference here? Yes. How would you know I'm going to do the square root method? How does this one look different from the one we just did with factoring? All right, and that means there's an x squared. Who's missing? The x is missing. All right, so if there's no middle term, then ding, 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 red flag. This is the square root method. The square root method, you want the squared term on one side and the number on the other. You do not want to put it in standard form. All right, so to get it looking like this, what do we need to do? Add 5 to both sides. So x squared equals 5. Yep. Now we have a perfect square on one side and a number on the other, and we can take the square root. The square root of x squared is x equals, and you are not going to forget to say, I'm hoping that if I keep saying that, it'll actually happen. Plus or minus. So how many answers is this? Plus or minus means there are 2 answers. And the computer loves you so much, it's going to make you write both of them. Oh, yes. For me, you are welcome to write plus or minus. The computer will not. So what are your 2 answers? The positive square root of 5 and negative square root of 5. So that's how the computer is going to make you put that in. Any questions on this one? All right, next, let's look at, switch over here, x squared equals negative 7. Notice that that is already in form to do the square root method. We already have a perfect square on one side and a number on the other. So what are we going to do? Take the square root. So take the square root of both sides. The square root of x squared is x. And when you do the square root method, you are not going to forget to write plus or minus. All right, now let's talk about this. There you go. The square root of negative 7. What's bothering us here is that negative sign, right? So we're going to take him out. Pull it out. And we're going to leave the positive part over here and the negative part over here. And by definition, what is the square root of negative 1? I. So we have x equals plus or minus I square root of 7. And once again, the computer is going to make you do what? Both. Plus or minus means the positive I square root of 7 and negative I square root of 7. So you just make it to an I the whole time? Anytime that you have a negative under the square root, you're going to have an I. What if you had negative 4? Then you would have, excellent question. You wouldn't have same thing right here. But what is the square root of 4? 2. And so this is 2, and it would be plus or minus 2i. Excellent question. So notice that they are assuming that you already have 320 skills ready to go. All right, moving on. Let's look at, notice here that there's 2 imaginary solutions, right? This one right here. The first one we did had 2 real solutions. This one has 2 imaginary solutions. Hang on to that because we're going to look at graphically what does that mean. All right, moving on. Everybody's favorite method of solving quadratics, completing the square. I see blank looks who are not yet immersed in the wonderful aura of completing the square. All right, so we're going to review completing the square. We're going to start with the easy one here. Notice the square root method. The square root method is there's a perfect square on one side and a number on the other. Is x squared plus 6x minus 7, is that a perfect square trinomial? The answer is no. So if we could make it into a perfect square trinomial, then you would have a perfect square on one side and a number on the other. So that's what we're going to do. We're going to force this into the square root method. All right, how do we do that? I'm so glad you asked. All right, step 1. Step 1 is, we just said, this is not a perfect square trinomial, right? So he's got to go. He's not working for us. So toss him out on his ear. We're going to throw the 7 onto the other side. Don't forget to change your sign. So now this is a positive 7. All right, so we said the negative 7, he's not working for us. So we're going to go find what does work. How do we find what does work? Well, I am very happy to say that this always works. Every single time, this perfect number right here is take the middle term, divide it by 2, and square it. It works every single time. So we're going to take the middle term, which is a 6, divide it by 2, which is, and we're going to square it. So 3 squared is, all right, so the perfect number that's going to create a perfect square trinomial is 9. So we're going to put it right here. Now this is an equation. Can you go around just sticking 9s in equations? Whatever you do on one side, you have to do the same thing on the other side. All right. X squared plus 6x plus 9. I bet there's some factoring demons out there. What does x squared plus 6x plus 9 factor to? X plus 3 what? Squared. That's the whole point. We are creating a perfect square trinomial. For those of you who are like, okay, I haven't done that in a while, who wants a shortcut, right? All right, so the shortcut is every single time this perfect square trinomial you have created is always x plus b over 2 squared. I love these guarantees. You know, life doesn't work that way. This always works every single time. So it is always x plus b over 2. What is b over 2? b over 2 is what was inside the parentheses before you squared it. So what was inside the parentheses before you squared it? 3. So what you have created is x plus 3 squared. Now this one is easy. You could sit there for a minute and you could factor that. But it's going to get harder. So wouldn't it be nice to have a sure thing? Every single time it factors to x plus b over 2 squared. Done. You don't have to sit there and factor it. Everybody say yay? Right? Equals. What is 7 plus 9? All right, so look at the magic. Nothing up my sleeve. We had something that was not a perfect square, and guess what? Ta-da! Now we have a perfect square. And if you have a perfect square on one side and a number on the other, what can we do? Take the square root. So we're going to take the square root of both sides. All right, so over here, what happens when you put the square root and the square together? Pow, pow. I used to say it was like my kids in the back seat of the car, right? Pow, pow. Those are inverse operations. They undo each other. So what's left? Equals. And when you do the square root method, you are not going to forget to say the square root of 16 is 4. All right, so very importantly here, what does plus or minus mean? There are 2 equations. So we write it down. X plus 3 is positive 4, and x plus 3 is negative 4. All right, so we're going to subtract. And once again, how many answers do we have? 2. So you're going to write it as a set. And we have a 1 and a negative 7. All right, any questions so far? Well, that brings us to, uh-oh. Now we got to do the harder one. All right, so let's take those steps that we did with the easy one, and let's see how those steps can help us when it just got more difficult. All right, so first of all, whenever you are completing the square, the very first step is that the leading coefficient has to be 1. So on the first problem, what happened? It was already 1. Yay! How about this one? No. So A has to be 1. It's not, it's 2. So how do we work magic? How do you make a 2 into a 1? We have to divide by 2. So we have 2x squared minus 5x minus 3 is 0. It is an equation, so you can do pretty much anything you want as long as you do what? Everything. So we're going to divide everything by 2. All right, let's start with the good news. What happens on the A? Which gives us? Yay. All right, so that's what we wanted. And over here, 0 divided by anything is still? Okay, what's the bad news? Oh, fractions. And no, there's no way to get rid of them. Yes, you have to deal with them. Minus 5 halves x minus 3 halves. That's life. Deal with it. All right? So we got a good thing here. We got a good thing here. Oh, yuck. Right? Now, I'm pretty sure that you can look at that and say, is that a perfect square trinomial? I'm thinking no, right? It's icky. So then step 1 is we're going to do what? Kick him out. Move it over to the other side. So now we have x squared minus 5 halves x, and I'll leave a blank there, equals 3 halves. And don't forget to change the sign. This is a very common mistake when you're doing completing the square. Don't forget it's moving over here and it's going to change signs. All right, next. We have to find what does work. How do we find the perfect number to create a perfect square when it's negative 5 halves? Right? Yuck. Thank goodness we have a sure thing. It works better than eHarmony, Match.com. Every single time it creates the perfect number. And the perfect number is take the middle number, divide it by 2, and square it. All right, so we have negative 5 halves, and we're going to divide it by 2. However, since this is a fraction, how do we divide when we have fractions? Multiply by the reciprocal. So negative 5 halves divided by 2 is the same as negative 5 halves times, there we go. So if you remember that, when the middle number is a fraction, dividing by 2 is the same thing as multiplying by 1/2. And if you remember that, it'll save you some time. Now, if you forget, do you still get to the same place? You're just going to say, I could have had a V8, right? So we have negative 5 halves times 1/2 is negative what? And wait a minute, we haven't squared it yet. So b divided by 2 squared. So negative 5/4 squared. How do you multiply fractions? Straight across. So negative 5 times negative 5 is positive 25. 4 times 4 is 16. And don't forget, whether it's positive or negative, if you square it, it's always going to be what? Let's try that again. Whether it's positive or negative, when you square it, it's always going to be Positive. So it is always going to be plus every single time. All right, who is Mr. Right? 25 over 16. And whatever you do on one side, do the same thing on the other side. All right, we are not done yet. There is more fun to be had. All right, now, when you looked at the x squared plus 6x plus 9, some of you could factor that and you had a perfect square. How about this one? I don't think so, right? So how about a shortcut? Every single time, this always factors to x plus b over 2 squared. Always, always, always. What is b over 2? It's what was inside the parentheses before you squared it. So what was that this time? Negative 5/4. So we have created x minus 5/4 squared. Isn't that a whole lot easier than sitting there trying to factor that thing? Right? Yay for shortcuts. And we're done on that side. All right, equals. All right, that's it for the good news. Guess what you get to do? Oh, come on, this is college algebra. To add fractions, you have to have a common denominator. You can do this. All right, we got 3 halves and 25/16. So our common denominator is? Up here, we need to multiply the 2 by 8. 3 times 8 is? 24/16 plus 25/16 is? Can you say rigged? All right, so now, after a whole lot of work, we have a perfect square on one side and a number on the other. Whew! And after all this, we can do what? Take the square root. Take the square root of both sides. What happens when you have the square root of a square? Pow, pow. They are inverse operations. They undo each other, which leaves you with? And when you do the square root method, you are not going to forget to write? All right, what's the square root of 49/16? And what does that plus or minus mean? All right, now I'll tell you a little sneaky trick here. We had to get a common denominator up here. There's no way around that. But when you get here, if there are fractions, these will always be the same. That's mathematical theory. If it's not the same at this point, you did something wrong, right? So now we're going to put them together, and they're guaranteed to be a common denominator. All right, solve for x. Add 5/4 to both sides. But what does this mean? There are 2 answers. So we have a positive 7/4 and 5/4, and we have a negative 7/4 and 5/4. But hey, they're the common denominator, right? Yay. 7/4 plus 5/4 is? Which is negative 7/4 and positive 5/4 is? Which reduces to? So how many answers are there? There are 2. And in either order, we have 3 and negative 1/2. Woo! And that is the hard one. But what I want you to see on the hard one here is we did exactly the same steps that we did with the easy one, right? So when you do a harder one, first of all, you need to remember that A has to be 1. And then secondly, go through exactly the same steps that you did before. Jason, you have a question?
Yeah. In the solving for roots,
Uh-huh. Yes. That's when you're factoring. The square root method, we don't put it in standard form right here. We want a perfect square on one side and a number on the other. Okay, we did the plus 7/4 right here, and we did the minus 7/4 right here, which left us with a negative 2/4, which is negative 1/2. So we did the plus and the minus. Anybody else?
Just one quick question. I did the part after the square root of the x minus 5/4.
Yes.
Now, to get the 25/16, didn't we do the same thing?
We squared it after that. This is the number before you squared it. Very important distinction. Yes. All right. Any other questions on the hard guy here? On which part?
After you divided b by 2, if you try to do something like that, I got lost.
To find the perfect number, you're going to take the middle number, divide it by 2, and square it. And then the perfect square trinomial you have created is x plus b over 2. That's what was inside before you squared it. That goes right here. So that's our two shortcuts. Okay. We're going to practice later on. All right. Let's move on here. Let's look on 3.2 if you've got your book. 3.2. And the new homework is going to open after class tonight, by the way. All right, 3.2. And we're going to look at number 10. It's page 253. All right, so what I want you to look at is I'm picking these examples from the homework so that when you look at them, you can identify what you're going to do. So what is the trick here that tells me I know how to do this problem? Who's missing? There's a middle term missing. Okay, what does that mean? That means we might have a square root method on our hands. We have a perfect square, we have a number, but what order do they need to be in? In order to use the square root method, we need a perfect square on one side and a number on the other. So how can we make this happen?
Add 20.
Move 20 to the other side. Now what? All right, so I always get a question on this. Should I take the square root now, or should I go ahead and divide? The answer is, it depends on this number. If this number is a 4, then tell me about 4x squared. It is a perfect square, so you could leave it. But in this case, we're going to do what? So 20 divided by 2. All right, so voila. Now we have a perfect square on one side and a number on the other. So what are we going to do? Take the square root of both sides. The square root of x squared is x. And when we do the square root method, you are not going to forget and how many answers is that? And the computer is going to make you do what? It's going to make you write them both, and you're going to be cussing at the computer. I can't fix this, all right? I will let you use plus or minus. All right, any questions on this one? Erica? Say that again? Oh, good question. Because this number under the radical is positive. If it was negative, it would have an I. Yes? Shaquille, you have a question? Okay. All right, let's see, we've got another one here. Number 20. Let's do number 20. You mean other than the hint underneath? All right, when you have 4 terms, you're going to factor by grouping. All right, so let's see if our grouping skills are up to snuff here. With grouping, we take a big, scary problem and we break it down into smaller pieces. So I have grouped the first 2 and the last 2. If that doesn't work, you can move them around. It's called grouping. You can create your own playdates. Right? It doesn't matter what order we group it in. But I usually try this first. I call it the good old college try. So let's see if it works. In the first group, what do they share? X squared. So we're going to take an x squared out of both of those. And when you do that, what's left? Notice here, x squared over x squared. Anything over itself is 1. You can't just say it's gone, because if you don't put the 1 here, when you distribute it back, you're not going to get this guy, right? Okay, second group. We need another 3x plus 1 to miraculously make an appearance over here. So what do we need to pull out from the second group to make this happen? -4. All right, so this is the whole idea of grouping. You notice that in the original problem, there is no common factors, right? But, whoo, abracadabra, now what do we have? Now they have something in common. If they have something in common, we can factor it out. So factor it out, 3x plus 1. And then we're going to take a 3x plus 1 out of both of those pieces. And what's left? But wait, we're not done yet. Tell me about this guy. All right, so on the test, it often says factor. That's right. Means factor completely. That means keep factoring until you can't factor anymore. So x squared minus 4 factors to all right, so this one is solving by factoring. How do we finish this up? Set each piece equal to 0 and solve. Oh, looky there. We actually have to work on this one. All right, so our 3 answers are -1/3 and what? A +2 and a -2. And once again, I would let you get away with plus or minus, but not the computer. And how many answers do we have this time? We have 3. We started out with a cube, and we have 3 answers. Tune in later in the chapter for more. All right, so let's see what we can find here for a completing the square. Number 34. Any questions on this one before we go on?
Oh, yeah.
Go ahead.
On the very first step,
Uh-huh.
3x cubed divided by x squared.
Yes.
Wouldn't that just be 3x?
Yes, right here. We took the x squared out. We factored it out. They share that, so that's what goes on the outside. And then the 3x is what's left when you do that. Anybody else? Okay, let's move on to completing the square. We're going to look at number 34. All right, let's get through 34 and then we'll take a break. All right, number 34. Hey, I gave you an easy one. All right, I'm going to let you work on that for a little bit. Look at your steps. Why is this an easier one? It is fewer numbers, but particularly what? The coefficient of the leading term is 1. That makes it the easier kind. All right, look at your steps. I'm going to let you work on this for a little bit. Solve for x. Did you do your plus or minus?
I'm not sure this would be subtracting it.
Okay, the last number is always going to be plus.
Okay.
Always. Did you finish? Solve for x. Okay, so that's the first step, is to get rid of him. The second step is to find out what does work, what creates that perfect square trinomial. Okay, we'll look.
Once I have that there, do
Okay.
I move it?
You add it to both sides.
Yeah.
Okay.
And then do I put it back over there or?
When you've added it to both sides, then you can go ahead and simplify this, and then you have created a perfect square. So you should have x plus something squared on the left side. No?
I subtracted 13 from both sides of step 1. Is that
Yes.
step? Oh, that's
Absolutely.
good. Okay. And that's what it is.
And that's okay.
So I made it down here.
Okay, so what is this? What is the square root of negative 4?
It'll be 2i.
Yes. And then solve for x. You're almost
So,
there.
I got that. Is that right?
Okay, this is the only thing you need to get rid of. We're going to keep the 6x.
Oh,
You
keep
just need to
6x,
toss
just
the
toss that
13.
out.
X squared is 6x plus 9.
It should have an I. All right, let's do it. What is step 1? 13 is not creating a perfect square for us, so he's got to go. Toss him out. All right, so now we have to find out what does work. And there is a magic formula every single time. How do you find that number? All right, so b is 6 divided by 2. And 3 squared is? All right, so our magic number is 9. And you have to add that to both sides. All right, we have created a perfect square trinomial. But which one? X plus b over 2 squared. What is b over 2? It's what was inside the parentheses before you squared it. So we have created x plus 3 squared. Negative 13 and a positive 9 leaves you with? Wait, we're not there yet. Negative 4. All right, so you did all that work so that you have a perfect square on one side and a number on the other. So we're going to do what? Take the square root of both sides. Square root and a square, what happens? Pow, pow, inverse operations. And that leaves you with? All right, now you can say it. Plus or minus. All right, what is the square root of negative 4? 2i. All right, so to get x by itself, move the negative 3 over. All right, now let's talk about this. On any planet, are these like terms? I have seen the most creative things to try to put those together. They are not like terms. So how do we write that? Negative 3 plus or minus 2i. Write the number first and then the radicals or the i's last. Number first, radicals last. Now, on the computer, how are they going to make you write this? Comma. So don't say I didn't warn you. All right, any questions on completing the square? All right, we're going to take a quick break. 5 minutes, come back. Julia, you look like you remember this from 320.
I got it framed in my head last time, so I'm going to do this part.
That's good.
Because I didn't know the circles, last time.
Oh, yeah. That part's new.
The
Yeah.
circles, and I just got, I think the first test I just blanked. I sometimes panic during tests. That's just one of my things.
The first and second test has a combination of 320 and some new stuff.
I'm gonna nail this other one.
Okay.
quadratic, that whole formula for this one. I like
We're going to do that next.
I actually don't mind doing those. Those are actually kind of fun. Now, I should say, you know what I'm saying, they're more, interesting if you have that formula memorized.
Yes.
But I heard you can get harder with them than what we did just in 320.
It's around 6:30. 6:30. Yeah, at the end I'll pick up all the ones that are left. Right, it's x minus d. X minus h in that case.
Okay. What did I do wrong here?
Which one?
On 16.
Okay. The test here, you got half credit because you did the test. That's good, all right? But apparently you didn't interpret that correctly. Okay, so when you replace x with negative x, then what happens? This part becomes negative, right? So a negative times a negative is a positive, right? This is negative, so that's negative. Now, then the question is that the same? No. So it is not even, right? So then the question is it odd? It's odd if it is the opposite. So what's the opposite of what you started out with? That would be plus, minus, minus. And guess what? That's a no. But you did the test. That's why you got half credit on that one. You didn't plug it in both places. You only plugged it in one place. You have to plug it in both places. Everywhere you see an x, you have to put a 2x plus 3. All right, hit them up, move them out real high. All right, I want you to put down your pencils, and I want you to watch me. You don't have to learn this. You don't have to memorize it. I just want you to follow what I'm doing, okay? So we found out that anytime you have a quadratic, you can complete the square, right? True? Every single time you have a quadratic, you can complete the square. So 100 years ago, somebody said, I am really tired of completing the square. Those problems took a whole page. So he said, what if I complete the square on a generic quadratic? That means A, B, and C can be anything. So that's what we're going to look at. You don't have to memorize this. You don't have to write it down. I just want you to watch me. All right, so step one. We cannot be guaranteed that A is 1, right? We don't know that. So we're going to assume it's not 1, and we're going to divide everything by A. So just like last time, we have the good news and the bad news. The good news is we get x squared, and we get 0. And what is the bad news? Fractions. Once again, we cannot be assured that this, whatever it is a perfect square. So we can't be sure, so we're going to toss him out. All right, so we have a magic formula to find the perfect number. The perfect number, take the middle term, divide it by 2, and squared it. So what is our middle term? So B over A, and we said earlier when you have a fraction, Dividing by 2 is the same thing as what? Multiplying by 1/2, and then we're going to square it. So what is b over a times 1/2? b over 2a, and then we're going to square that. So square the top, that gives you, and then what is 2a times 2a? Keep going. 4a squared, there you go. So our perfect number, as strange as it may look, is b squared over 4a squared. So we're going to add that to both sides. All right, so seriously, thank God for that shortcut now, right? I would not want to have to factor that. But every single time we have created x plus b over 2 squared. And what is b over 2? It's whatever was inside the parentheses before you squared it. So that was what? b over 2a. So x plus b over 2a squared, that's what we created, equals, oh, looky there, we get to practice from 320. To add fractions, you have to have a common denominator. So we've got an a, we've got a 4a squared. So our common denominator is? All right, so we got an a. We need a 4a squared. What's missing? Do the same thing on the top. So that gives us negative 4ac. So that gives us, put those together. Now that you have a common denominator, if the denominators are the same, all you have to do is add the numerators and keep the denominator. So that gives us b squared minus 4ac over our common denominator, which is, all right, so as strange as it is, that's what's over here. Okay, now, that looks pretty weird, right? But if you knew what a, b, and c were, this is just a number. You would plug it in. This is just a number. So we have a perfect square on one side and a number on the other. Where have we seen this before? So now we're going to take the square root of both sides. So when you do that, on the left-hand side, pow, pow, that leaves you with x plus b over 2a. And on the right-hand side, you are not going to forget to write. And we have the square root of b squared minus 4ac. But how about this guy? What's the square root of 4a squared? 2a. Now, I promised you, you probably didn't understand at the time, but I promised you that at this point, if you have fractions, these are always going to be the same. That's mathematical theory. It's always going to be the same. So if you have like denominators, yay, then we have, let me write this down. All right, so if we have like denominators, we're solving for x, subtract, and when you do that, we have x equals. All right, so if the denominators are the same, then all you have to do is add the numerators and keep the denominator. So that gives us negative b plus or minus the square root of b squared minus 4ac all over, otherwise known as that's the real thing. Wow. So what is the quadratic formula? Let's look back. What did we start with here? Ax squared plus bx plus c equals 0. We started with a generic quadratic. A can be anything, B can be anything, C can be anything. And we completed the square, which means we solved it. We solved that, and we got this. So what is this? The quadratic formula is the answer to every quadratic in the world. You're not appreciating this. That means if you could have done the square root method, this works. If you could want to check you're completing the square, this works. If it will factor, guess what? This works. It is the answer to all of the questions. Does this mean I'm not going to force you to do completing the square? Yeah, good luck with that. Right? It's going to say you have to do it by such and such a method. But if you have a choice, the quadratic formula always works. All right, let's try one. All right, so we're doing the first one here. We have 5m squared plus 3m equals 2. All right, so first of all, and probably most importantly, is where did we start? Way back at the beginning, what did we start with? We started with ax squared plus bx plus c equals 0. In other words, in order to use the quadratic formula, your quadratic has to be in Is this in standard form? No, it is not. So we have to put it into standard form. So what do we need to do on that first one? The 2 needs to move. All right, so that wasn't too bad. Oh, we'll get to those later. All right, so right now, it wasn't that hard to put it into standard form, right? Not too bad. So now that it is in standard form, now you can look at what is A, what is B, and what is C. It's very easy to read those off. So we have A is what? 5, B is 3, C is -2. Don't leave your sign in the dust there. -2. And all you have to do once you've done this is plug it in. So let's practice. X equals -b. So that would be -3 plus or minus the square root of b squared. That would be, which is 9, minus 4 times A. A is 5. And C is all over 2A. A is? All right, so I have plugged it in. We have to clean it up. All right, so let's see what we can do here. First of all, biggest mistake I see on these is this guy right here. 4AC means 4 times A times C. It is 1 chunk, right? 1 chunk, 4AC. So what is 4 times 5 times -2? 20 times 2 is 40. A negative times a negative is a positive. So 9 plus 40 gives us what? Oh, can I rig those problems? X equals -3 plus or minus the square root of 49 all over 10. Are we done? We are not done, because what is the square root of 49? Whenever you have the opportunity to take a perfect square, you do it. You get so used to those other harder ones that you forget. Take the square root when you have the opportunity. So we have x equals -3 plus or minus 7 over 10. Are we done now? If I had $1 every time people left it like this. All right, you did all the work. All you have to do now is what? Plus or minus. All right, so let's see what we got here. -3 plus 7 over 10 and -3 minus 7 over 10. 7 minus 3 is, and 4/10 reduces to, always reduce your fractions. -3 and -7 divided by 10 is, so this time we have 2 normal answers. This doesn't happen very often. All right, so if you get normal answers, you write it as a set. 2/5 and -1. All right, any questions on the first one? All right, so obviously the big question is, you expect me to memorize that? Of course I do. But we have a cheat. We're not there yet. Back. Okay, let's go over here. Oh, I had this working earlier. Hold on. Oh, did I? Okay. Okay, let me back it up. Did I just turn the volume down? I thought I backed it up.
You go up to the circle. The bar, the red bar is.
Red bar. Thank you.
Only there was a
This is why I let my kids do that.
Well, here's one. In fact, to solve any quadratic equation, all you need is the quadratic formula. Here's a song to help you remember the state of Oscar Salido. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. Now you try.
All right, come on, guys. Quadratic formula is -b plus or minus the square root b squared minus 4ac all over 2a. Yay! So if you go to YouTube and you go to COM, okay, I don't know what that is. If you go to YouTube and you go to Quadratic Formula, COM, you can find it. Oh, that's, okay, where is it? Okay, honey, come on.
Good job, Emily. What about the x equals?
So if Emily can do it, you can do it. Right? She was the daughter of one of our adjuncts a few years ago. I love that one. Okay, so yeah. All right, so we are going to go back now and do another quadratic formula here. Yeah, as soon as I go back to the right slide. There we go. All right, let's do the second one. All right, give it a shot. Singing optional. Oh, we're going to do it on the board. All right, we ready to plug it in? First of all, is this in standard form? Aren't you lucky? A is, B is, C is. All right, so we have x equals, you ready? Negative b plus or minus the square root of b squared minus 4ac all over 2a. Yay! All right, so make sure that you write down the quadratic formula, because if you don't put the plus or the minus, the negative signs in the right place, it is no longer the quadratic formula. Now it's Bob's formula, which is not going to work, right? You have to have it exactly. So sing in the shower, do whatever it takes. Make sure that you have the quadratic formula. All right, let's clean this up. 1 minus 8. So we have x equals negative 1 plus or minus the square root of negative 7 over 2. We looked at this guy earlier. What does that mean? We got an I. So we have x equals negative 1 plus or minus, what does that reduce to? I square roots of 7 all over 2. And guess what you get to do on the computer? Oh, that's fun, right? Negative 1 plus I square roots of 7 all over 2. Negative 1 minus I square roots of 7 over 2. I have talked to them. They will not put it in there. So yes, you have to do it. For me, plus or minus is fine. Any questions on this one? All right, so let's look at simplifying. Let's say that you did a problem and you ended up with, okay, let's say that you ended up with 6 plus or minus the square root of 24 all over 2. And you put that in the computer and it said, why is this not the answer? You have to do a whole lot of simplifying. All right, let's start with the 24. Once again, we are in college algebra. They assume that you have already got the skills to break this down. 24 is not a perfect square, but does it have a factor that is? All right, what is the square root of 4? So now we have x equals 6 plus or minus 2 square roots of 6 all over 2. And you put that in the computer, and again it said, what's the problem now? Miss Morowski, did anybody have her? All right, awesome. Miss Morowski says, Mickey Mouse. If you can draw Mickey Mouse, you can reduce. In other words, all 3 pieces have to have a common factor. If this one doesn't have a common factor, Mickey Mouse lost an ear. Not pretty, right? It has to be all 3 pieces. So what is our common factor? 2. So 2 divided by 2, 6 divided by 2. 2 divided by 2. So we have x equals 3 plus or minus the square root of 6. And that is your final answer. And no, you don't have to write the ones. If you wrote the ones for me, it would be fine. It's the same thing. But the computer's not going to know that that's the same thing. It's going to say, right? So if you have 5 over 1, do you write 5 over 1? You just write 5, right? So that's why this one is not written. If you have 1 square root of 6, that's the same as the square root of 6. Now, what if this was a 2? If this was a 2, 2 divided by 2 is, and you have to write that one. That's your real part. You have to write that one. But anything that means the same, you don't have to write. All right, any questions on reducing? All right, last but not least, let's look at the discriminant. When you have the quadratic formula, you have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, if you look at the problems that we did, those 2 that were up there, there they are, you notice that the first one, your answers were real. On the second one, what did you get? So the question is, what causes that to happen? What causes one to be real and one to be imaginary? A negative number where? So if I wanted to find out whether something was real or imaginary, I don't have to do the whole hunkin' thing. All I have to do is check what? Just this guy. So this guy right here, b squared minus 4ac, just that tiny little piece, is called the discriminant, because it discriminates between real and imaginary. All right, so if you have this guy right here, and you get the square root of 13, right? The square root of 13, that is 2 real solutions, right? What if you get plus or minus I square roots of 3? 2 imaginary solutions. So this right here would have been the square root of negative. So if this number is negative, then you have 2 imaginary solutions. If this number is positive, you have what? 2 real solutions. And last but not least, if your b squared is the same as your 4ac, what happens? The square root of 0 is 0. All right, so this is called the discriminant. Now, why would we need this information? If you're doing a math problem, it doesn't matter if it's imaginary. You better do it. If it is a real life problem, and your answer is negative I square roots of 3, is that going to be helpful? No. So instead of taking the time to do the whole honking thing, wouldn't it be nice to know ahead of time whether your answer was real or imaginary? Yes. Because if the answer is imaginary, you don't even have to do it. Yay, right? Throw it out. But if it's real, then you can go back and get those exact answers. It saves you time. How many and what do they look like? The question here is going to be the nature of the solutions. All right, so let's look at the, let's see here. All right, so that's the question. Determine the nature of the solutions. It didn't say solve. We do not have to find the answers. I want to know, what do the answers look like? Do it. All right, so we don't have to do the whole quadratic formula, do we? All we have to do is the discriminant. What is the discriminant? Just that one little piece, b squared minus 4ac. It's the piece under the radical. So that would be b squared, 9, minus 4ac, 9 minus 16. I don't even have to do anything else. Okay, which part? All of it? Okay, you got 1, 3, and 4? You got that? Okay. This is the discriminant. That's inside the radical. So we're going to plug that in. And what does this tell you? I do not even care a whiff what that number is. All I care about is it is negative. And if it is negative, what does that tell you? 2 imaginary solutions. There we go. So notice the question. It did not say solve. It says determine the nature of the solutions. All right, we're not done with this section. We've got 2 more pieces we'll do on Tuesday, but this is most of it, so you can get started on that homework. All right, so you can go. You guys are going to work on some work. All right, turn to page 254. Page 254. No, he can go. I did not say Jason.